Hello, I'm here to give you 69 facts about SDL GPU. I'm Evan. I've been a member here for 10 years. Wow. Ported some games to consoles. I maintain a bunch of open source game tools. I'm programming Samurai Gun 2. Let's move on. So the problem, you need hardware acceleration to make your games run good. Otherwise, they won't run good. So the graphics processing unit is a special chip on your machine that makes the game run good. So you access this acceleration via a graphics API. There are a lot of different ones. They're all on different platforms. The older and simpler ones, like OpenGL and D3D11, are becoming obsolete, and the newer, faster ones, like Vulkan and D3D12, are much more powerful, but very difficult to use. There's also crazy levels of cross-platform fragmentation. So if you want to write a renderer that runs on every platform, you're fucked. You need to support, at minimum, 4 different APIs, for older hardware, you probably want to support like D3D11 or OpenGL. PS5's in its own weird world. So this is a huge challenge for game developers. So what's the solution? So SDL is a widely used open source platform layer. It's written in C. It's very portable. You write platform code once. You run it everywhere. It does stuff like file systems, input handling, window management. You can just write the code once, and it runs on everything. Your favorite game probably uses it. It's incredibly popular. So we're thinking, why can't SDL make rendering portable too? So here in comes SDL GPU, which is what I've been working on for this whole year. The idea is you write rendering code once, you run it everywhere. We've got Vulkan, D3D12 Metal, PS5 kind of working, D3D11 for legacy systems, minimal boilerplate for if you want to just draw a triangle on the screen in Vulkan, you're looking at probably 1,500 lines of code. For us, it's about 150, much better. We've got all the fancy goodies that you could possibly want for a renderer, threading, data transfer, all that fun stuff. Really good pipelining. It runs on anything made in the last 12 years. It's really nice. So here's an example really quick. This is just drawing a blue screen in 20 lines of code. If you want to do this in Vulkan, I will see you in 3 weeks when you finish writing it. So shaders, we're not opinionated about shader languages. You can use HLSL, GLSL, WGSL, whatever you want. Just bring your own shader workflow. We'll take any bytecode accepted by the backend. So you can do offline compilation, online compilation, whatever you want to do. The tooling situation is pretty good right now for just like shader cross compilation. So like there are tools like Spear vcross and DXC and Naga that we don't have to maintain. We do provide a satellite library that kind of glues some of this stuff together. It's called SDL GPU Shader Cross. So just getting started really quick, you can just pull in our library and it will do a lot of the upfront stuff for you. One day we'll have our own compiler and bytecode, hopefully. It's probably going to take a while, and you don't need it right now. So as a comparison between our solution and similar solutions in this space, you can see this line of code chart. So Google Dawn coming in at a whopping almost 900,000 lines of C++ code. We are at just about under 50,000 lines of C code for roughly the same feature set. So my conclusion, stop using C++ for this stuff. Oh my God. Please don't do object-oriented programming for low-level programming. It really sucks. I mean, look at it. What are we doing? Look at this. So why don't we have X feature? So our goal with this project, maximum portability, minimum effort for you as the client. Certain advanced features are not well supported on older hardware, or they require you to bifurcate your renderer, so you have to write 2 different paths depending on the hardware that people are running the game on. That sucks. We don't want you to have to do that. So we've chopped some features, just like advanced stuff. Like you don't need ray casting in your game. I'm sorry. Sorry, it's ray tracing. Yeah. So to do, we're targeting the SDL3 public release, which is going to be very soon, hopefully. We're still working on PS5 support, should be ready soon. We're also going to write a tutorial series that will explain how to do various useful rendering techniques in our API. Thank you to Caleb Cornett and Ethan Lee, who are my F&A co-maintainers. Couldn't have done this without them. Thanks to Ryan Gordon and Sam Lentinga, who maintain SDL and do a great job. And thank you to Relogic for giving us money to work on this. And thanks to Glitch City for being a great place to work. So I really think this can be a game changer. I wrote it because I really need it, and I think a lot of people could really make good use of this. I think there's a lot of creative space to be found right now in between something like a standard Unity render pipeline and AAA's photorealism fetish. A lot of creative space to explore there, and I'm really excited to use this. I'm really excited for you to use this. Thank you.